I'm first going to start. Hi, we're working on correlation today. I'm first going to start by running a histogram to determine if the variables are normal. What we're looking for is free reduced lunch, and we are looking for math exceed. Oops, free reduced lunch, math exceed charts. I'm going to look for a histogram. I want to show the normal curve on the histogram. I want to say okay. Just because I want. Nah, I don't think I need anything on this screen, so I'm going to say okay, and then I'm going to say okay. So I realized I should have turned off the what is it called, the free reduced lunch thing, or I'm sorry, the frequency thing, or the frequency table. But anywho, looking at the free reduced lunch, it looks like it looks like it's reasonably normal. And looking at math exceed variable, it looks like it's pretty normal as well. We're going to look and see if there's a linear relationship as well as the homoscedasticity. I probably mispronounced that, but it's the part that shows that the center is wider, and then as you get to the end of the data, it's narrower. So I'm going to do a chart builder. I don't know what this means, so I'm going to say okay. Anywho, I'm going to do a scatter plot. I had the hardest time while I was practicing this to get a line to show up. I'm going to do free reduced lunch, as we learned in the what's it called, the lesson. It doesn't matter which axis things go on. And then I'm going to say, here we go. Was that? I think I did that right. And then I'm going to say total. And then I'm going to say okay. Okay, great. The line showed up. I couldn't get it to do it in the practice. So this looks to be a negative. Whatever the correlation is going to be, it looks like it's going to be negative, just because it's sloping downward. It does look narrow. It does look narrower on the ends, and it does look wider in the middle. So the homoscedasticity is okay here. So we're going to proceed onwards and upwards to the rest of these tests. Also, I'm just seeing that there's like an r squared linear equals 0.484. I don't think that's what we're looking for necessarily, so just ignore that part. And now we're actually going to run the correlation test. So this is where I'm going to probably mess something up. It is under correlate, bivariate. I'm looking at free reduced lunch and math exceed. I'm going to run a Pearson because we satisfied the requirements that this is a continuous variable, that it is a normal, homoscedasticity is good, and it's a linear relationship. So I'm going to say okay. I think I want to look at options. I think I'm okay with that. Let me make sure style. Yeah, okay. And then I'm going to say okay. Here are our results. Results show that a Pearson correlation. Results show a Pearson correlation of R equals negative 0.696 with the significance of P being less than 0.001. This indicates a statistically negative relationship. So much like that line was sloping downward, there's a statistically negative relationship. This is rather meaningful as the correlation strength is reasonably strong. Practically, this means that as poverty increases in a district, math scores tend to decrease substantially. This suggests that additional funding is needed for these districts. So, as what is very interesting related to this is because one of the variables is free reduced lunch, is what happens in districts / states that move towards a lunch is free for everyone, and breakfast is free for everyone as well. Like, what does that do? Will will there be changes, or will there be increases in test scores because of that? It would be interesting for future research to look at the impact that moving towards free lunch for everyone, what that would impact, or how that would influence the math exceeding the math test scores. And I was recording. Good.